Okay, so today you guys are going to be learning about place value. You're going to be able, by the end of this lesson, to recognize that in a multiple digit number, a digit in one place represents 10 times as much. So, I know you guys have heard this many times. Behind here on the wall, we have a ones place, tens place, hundreds, thousands, 10,000, 100,000s, millions. We will start focusing on the decimals later. As of now, we are only focusing on the left side. So our whole numbers, okay? We're going to learn how to tell what those numbers are. So if I give you the number 157, there's 7 ones, 5 tens, and 100. I'm going to teach you how to know that. This is also going to help you guys greatly because a lot of you guys cannot say big numbers. When you learn these number places, you will be able to better do your math, and you'll be able to better say big numbers. A lot of you will look at a number and get confused. This is going to help you not be confused when you know the place value. Why do you want to know this? Well, place value is literally the base of all math. It's going to help you with your addition, your subtraction, your multiplication, your division, your algebra, all of that. So you're going to be able to progress in math. When you go places, place value, money is all about place value. Remember when I tell you do not get rid of your decimal? There is a reason for that. For example, if I put 0.30, that's 30 cents. If I put 30.00, that's $30. I'm going to be able to teach you guys how to do that. You'll know you understand it when you can tell what place value a certain number is in. So if I give you the number 10, I say what place value is the 0 in, you should be able to tell me the ones. If I say what place value is the 1 in the number 10, you should be able to tell me the tens. The question you're trying to answer is how can I read a large number correctly? That's a big issue for a lot of you. How can I read the number correctly, a large number? In the real world, this can be used for money. For baking, you might need to know how to add your decimals. For shopping, for cooking, and for a job. If you're an accountant somewhere, you think they want you somewhere where you don't know place value, you're going to mess up their whole money scheme. Like everything. Their whole checkbook is going to be messed up. You need to be able to know place value so you can be a successful member of society one day. How would you feel growing up not knowing your place value, not knowing how to say a large number? It's embarrassing. How would you feel when you don't know if you have enough money or not because you can't read your place value and don't understand where your decimal belongs? You don't know that. You might be in the store and say, oh, it might say 30.00, which means $30. And then you might say, oh, it's 0.30, which is 30 cents, and be totally off. And then when you get to the cash register, you don't have enough money. That's embarrassing. So we're going to learn how to do that. On your desks, you guys have a place value note taker. This is for you to follow along with the video. You are not supposed to be trying to do it beforehand. This is stuff that this video is going to go over with you. Any questions before you begin? Okay. Can you make 25 of these, please? Thank you. Or do 30. Thank you. Yes, please. Okay. Let me make sure the volume is up. Follow along with your notes.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn how our basic number system works, and we're going to learn about an important concept called place value. The number system that we use in math is called base 10, because it uses 10 different symbols for counting.
What's the numbers, symbols that we use in math? It's called a base what?
10.
Base 10. Before he starts explaining why it's called base 10, does anybody know why it's called base 10? Does anybody know why it's called base 10? No? Okay. So when we count, we go 0, What comes next? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, wait, stop there. Then we start getting into double digits, right? Which is 10, which is written as 1, 0. So our base 10, if we go from 0 to 9, how many numbers is that? 90. No, 0 to 9. How many numbers is that? So look at my fingers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many fingers is that? 10. So why is it called base 10?
Oh, 9 numbers.
Yeah. A lot of us forget that what is a number. A lot of us forget that what is a number. You want to hear me count again?
Yeah.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What number in there do a lot of us forget?
10.
No. 10, remember, 10 is going into... Yes, thank you. 0. A lot of us forget that 0 is a number. Haven't you wondered why when I count up to 9, there's 10 numbers? 0 is a number. Is 0 a number?
Yes.
Yes. Okay.
Use other systems that are based on a different number, like base 2 or base 8, but I'll give you 10 guesses as to why the number 10 is such a popular choice. The 10 symbols that we use are called digits, and they look like this. 0.
What are the 10 numbers that we use called?
10 digits.
Digits. Digits is another word for number. What's another word for number? Digits.
1, 2, 3, 4, 5, 6, 7, 8, and 9. At first glance, you might think that that's only 9 digits, but remember, the 0 counts as one of the digits also. To see how our number system uses these digits to represent amounts, let's pretend that we have an apple orchard full of apple trees, and each of these trees is loaded with big, juicy red apples that we need to pick and then count for our records. We're going to use something called a number place to count. The best way to understand a number place is to imagine that it's like a small box that's only big enough to hold one digit at a time. As we count...
So what is each box going to be called? A blank place. What is it?
A number place.
A number place, okay? Are we understanding so far?
Yes.
Okay.
We'll change the digit that's in the number place to match how many apples we've picked. For example, if we start with no apples at all, we put the digit 0 in the number place, because 0 means none. But then, as the apples start coming in from the orchard, we begin to count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now we've got 9 apples, but we've also got a problem. We've already run out of digits to count with. The highest digit we have is a 9, but there's a lot more apples left to count. What will we do? The solution is to use groups to help us count. If we pick just one more apple, we'll have 10, right? So let's combine those 10 apples into a single group. So, how many apples do we have? 10. But, how many groups of 10 apples do we have?
9. Okay, so at first he counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So he went through the whole base 10, correct?
Yes.
Then he said, wait a minute, we have so many more apples to count. And he said, we can start putting them into groups. Okay? So then he picked one more apple. He got 10. He put them into the basket. That represents one group. How many groups does that one basket represent?
10.
Thank you. Good job. How many how many groups does the 10 apples represent?
1.
One. That is one group of 10, okay? What if he had 2 baskets full, both of them had 10 apples? How many groups of 10 would that be?
2.
2. Okay, so then when you think about that, what number would that be? How many apples in total would he have? If there's 10 in one basket, 10 in another, all together, how many would he have? 20. Good job. Now let's think about this. You guys are telling me that there's 2 if there's 2 baskets full of 10 apples, right? There's 10 apples in here, 10 apples in here. Jocelyn said, altogether, there are 20 apples, okay? Are we all in agreement here?
Yes.
How many groups do we have?
2.
Look at this. 2
20.
groups
20.
of
10.
10. So what place value do you think this is? The
10.
10s.
I
Look
did-
at that.
This is one.
What group value would you think this is?
1.
Ones. Is this starting to make sense?
I remember this now.
Okay, we're going to keep going.
Ah, just one. Does that help us with our lack of digits problem? It sure does, if we use another number place. Instead of using this new number place to count up individual apples one at a time, like we did with the first number place, we're going to use it to count apples 10 at a time. In other words, we'll use it to keep track of how many groups of 10 apples that we picked. For example, if we've picked only one group of 10, then we'll put the digit 1 in that number place. If we pick 2 groups of 10, then we'll put the digit 2 in that number place. And if we pick 3 groups of 10, then we'll put the digit 3 in that number place, and so on. Do you see what's happening? Because the new number place is being used to count groups of 10, it's allowing us to reuse our original 10 digits. But this time, they're able to count, or represent, bigger amounts. Since this new number place is for counting groups of 10, we're going to name it the tens place. And we'll name our original number place the ones place, because we used it to count things one at a time. And here's the really important thing. We're not going to use the new number place instead of the old one. We're going to use it alongside of the old one, so that we have one number place for counting by ones, and another number place for counting by tens. Using these two number places together lets us represent amounts that are in between the groups of 10. For example, if we've already picked 30 apples, then there'll be a 3 in the tens place because we have 3 groups of 10. But there'll be a 0 in the ones place because there are no individual apples left over. But if we've picked 32 apples, then there will be a 3 in the tens place and a 2 in the ones place to represent the 2 individual apples that are not in the groups of 10. In fact, using only our 10 digits and these two number places, we can count all the way from 0 up to 99. At 99, both of our number places are maxed out with the highest digits. And we won't...
Okay, so let's stop here real quick. What do you think is going to happen after 99? What number comes next?
100.
100. But in each of these groups right here, remember they told you only one number can go in there?
Yeah.
So what are we going to do?
Another box.
Yes, we're going to add another box. And if the number is 100, what place value do you think is going to be next?
Another box.
No, this is the ones.
This is
10.
tens.
This is the tens.
The 100.
The hundreds. Is it starting to make sense?
Yes.
Good. Okay. So. Oh, can you turn off the lights, please? Thank you.
able to count any higher unless we get another number place. If we pick 99 apples and then we pick just one more, we'll have exactly 100 apples. And if we make a group from those 100 apples, we can use this new number place to count how many groups of 100 we've picked. That means that we can reuse the same 10 digits again in this new number place to count how many groups of 100 we have. And you guessed it, it's called the hundreds place, because we use it to count groups of 100. Are you starting to see how our base 10 number system works? It uses different number places to represent the different size groups that we use to count. And the digits in those number places tell us how many of each group we have. The digit in the ones place tells us how many ones we have. The digit in the tens place tells us how many groups of 10 we have. And the digit in the hundreds place tells us how many groups of 100 we have.
Are we understanding so far?
Yes.
Okay.
Have you noticed that each time we got a new number place to count larger groups, we placed it to the left of the previous number place? That's important because number places are always arranged in the exact same order. Starting with the ones place, as you move to the left, the number places represent larger and larger amounts. And did you also notice that each new number place represents groups that are exactly 10 times bigger than the previous number place? 10 is 10 times bigger than 1.
So, how many times bigger is it going to the left? How many times did they say?
0.
No. How many times
10.
bigger? 10 times bigger. Every time we go, it increases by 10 times. That means times 10, okay? Any questions about that?
No.
100 is 10 times bigger than 10. That's really important because it helps us see the pattern for even bigger number places. It helps
So-
us to see that the next
Looking at this number right here. Oh, wait, hold on.
pattern for even
Okay, looking at this pattern, what do we notice about this pattern? So here we started with a 1, then we got to a 10, then to 100. I'm going to give 20 seconds of thinking time. Hold on, okay?
I know the answer.
Keep it to yourself, please, until we get there. I'm asking you, what do you notice about this pattern as it increases? So this 1 represents the ones place. This 10 represents the tens place. And what place value is this? Just yell it out.
100.
This is the hundred place. That means there is one group of 100. Okay? Now, when you're looking at this, as it's increasing from this box down to this box to the left, we start with a 1, it goes to a 10, then 100. So looking at this pattern, what do you notice about it?
Increasing the number.
So yes, the number is increasing. What else do you notice about it? It's going least to greatest. What else do we notice? There's a big pattern here that's going to help you remember your numbers place. Okay, so let's look at the zeros. What's happening?
It's increasing the numbers.
It is increasing in numbers. We heard that answer already though. Look at the zeros, you guys. What's happening? It is getting bigger, yes. So we got that answer already.
Adding more zeros.
Yes. So look over here. That one was for 5. So here's a 1. Are there any zeros?
No.
No. This is the ones place, okay? Then we're going to add a 0 here. What place value is this?
10.
The tens place. How many zeros do we add here?
100.
This is the hundreds place, but how many zeros does it have?
2.
2. So we went from 0, 1, 2. So how many zeros do you think is going to be here?
3.
3. And this would represent what place value?
1,000.
The thousands. Good. Okay. Is this starting to make sense? This is going to help you greatly in reading your numbers.
I remember this. I need to flip that.
bigger number places. It helps us to see that the next number place will count groups of 10 times 100, which is 1,000. That's why it's called the thousands place. And the next number place will count groups 10 times bigger than that. It's the 10,000s place. And the number places keep on going like that. Next is the 100,000s place, then the millions place, then 10 millions, then 100 millions, then billions, and so on. Oh, and you may notice that when we get a lot of number places next to each other like this, it's a little hard to quickly recognize which place is which.
So if we had a number that was that long, right? So each box would have a number in it. Do you notice that your eyes would get tired of reading that?
Yeah.
So what do we use? What do we use to help us separate? What?
Glasses.
Not not glasses.
I know what.
What do we use? What do you see in numbers?
A comma.
A comma.
Comma.
Good. We use a comma. Now, you know how you all get confused on where to put commas
Yeah.
in your numbers? This is going to help you. So pay attention, okay?
Why many countries use some kind of separator every 3 places to make them easier to keep track of.
So every, how many places?
3.
Every 3 places you put a what?
A
comma.
A comma. So here's the ones place, the tens place, the hundreds place, comma. Here's the thousands, the
10,000.
10,000s, the
20,000.
No.
2,000.
2,000.
So this was one?
100,000.
Yes, good. So this was the one hundreds. There's a pattern here, okay? Then it goes thousands, 10,000s, 100,000.
A million.
A million.
Millions,
2 million.
not 2 million, 10 million, 100 million, billion. And we could keep going on and on and on. The number will never end.
Wow.
Okay? So do you see the pattern? 1, 10, 100. Then we go to 1,000. Then 10,000, 100,000. Then to million. 10 million, 100 million. Then to billion. And if I wanted to keep going, it'd be 10 billion, 100 billion. So all we're doing is repeating those. And after how many numbers do we put a comma?
3.
3. Good job. 3. After every 3 numbers, we put a comma.
For example, in the US, we use a comma every 3 number places to make it easier to identify things like the thousands place or the millions place. Seeing all these number places together helps you understand what we mean by place value. In a multi-digit number, the number place that a digit is in determines its value. Even though we only have 10 digits, each digit can stand for different amounts depending on the place that it occupies. If the digit 5 is in the ones place, it just means 5. But if a 5 is in the tens place, then it means 50. And if a 5 is in the hundreds place, it means 500.
Nice.
And it's the same
Good
for
job.
bigger number places. A 5 in the 100,000s place means 500,000. And a 5 in the billions place means 5 billion. See how a digit's place affects its value? Of course.
Do we see why this is important for money?
It gets bigger and bigger.
Yes. Do we see why this is important for money?
Yes.
Remember, every time I'm asking you guys to pay attention to your place value, there is a reason. Are we starting to understand the reason why I constantly tell you that?
I could.
So, if the 5 was here, this would just mean 5, right? So if we were talking about money, it just means $5, right?
It gets bigger and bigger.
But if the 5 is all the way in this place value, it's
$5
$5 billion.
billion.
Do you want to mess that up on your check?
No.
Okay. It's a
I want that.
huge difference, okay?
Imagine you
Exactly.
got all that money.
And if you guys don't know about place value, what if somebody is trying to scam you? What if you work and you don't get all your money because you don't understand your place value? It's important.
You'd be like, ooh, mommy.
When we work with numbers in math, most of the time the number places are invisible, but the underlying pattern is always the same. Oh, and because the number places are invisible, in certain cases you'll need to use zeros to make it clear what number you're talking about. To see what I mean, imagine that this 5 is in the hundreds place to represent 500.
Okay, so if that 5 is in the hundredth place, which means he has 5 barrels of 100 apples each, we can't just put a 5, otherwise that would be the ones place. What is he going to fill these in with?
Zeros.
Zeros. The ones place and the
Tens.
tens place is going to have zeros, and then the 5 will be 100. So look at how we read this. It gets even easier. What place value is this?
500. Oh, no.
The hundreds. This is the hundreds. How many hundreds do we have?
5.
So we would read this as 500. Got it?
Yes.
This is going to help you guys so much in math.
I love
No,
it.
well,
But if you make the number places invisible, then it just looks like 5 and not 500. So, to make sure people know you mean 500, you need a 5 in the hundreds place, a 0 in the tens place, and a 0 in the ones place. Now you can tell that the 5 is in the hundreds place and it means 500. Okay, now a great way to see place value in action with some actual numbers is to expand them to show that they're really combinations of different groups. When we do this, it's called writing a number in expanded form. For example, we can expand 324 to be 300, 20, and 4. Because the 3 is in the hundreds place and means 300, the 2 is in the tens place and means 20, and the 4 is in the ones place, so it just means 4.
Okay, let me explain this a little bit. Okay? So this is our what place?
4 ones.
Ones. This is our tens place?
100.
100 place. So in the ones place, those are the individual apples he picked. Remember that? They're not in a group yet, okay? Those are individual. They're a base of 10, so 0 through 9. This number could be anywhere from 0 through 9. This number could be anywhere from 0 to 9. And this number could be anywhere from 0 to 9, okay? But once we start making a group,
add another
Yep, we add another group, right? Another box. So when we read this just as 4, okay? Now, remember we went back and I said if there's 2 groups of 10, how many apples do you have?
We're not only increasing the number, it's also increasing the box.
Yeah, we get more boxes, right? So if we have 2 groups of 10, how many apples in total are there?
20.
20. So look at this. Here's a 20. And for the 4, there's a 4. And over here, if we have 3 groups of 100, how many apples is that? 300. Look at this. 300. So this is how we would read this number. 324. If you have a hard time seeing that, you break it down. 3 hundreds, 2 tens, which would be 20, and 4. 324. This is how we read our big numbers. It follows the same pattern over and over, no matter how big the number gets. Any questions so far?
No.
Okay.
So 324 in expanded form is the combination of those amounts. 300 plus 20 plus 4. Let's try writing another number in expanded form. 6,715. We can expand this.
6,715. Everybody get a Post-it, and I want you to try writing it in expanded form. 6,715. So before you start that, let's go over this. What place value is this? 1. This one?
1.
No. Eyes up here, please. Eyes up here, please. What place value is this?
1.
Ones.
10.
Tens.
100.
Hundreds.
1,000.
Thousands. So now write this in expanded form, please. Nice. Good job. Good job. Where's my workbook?
Expanded form is used in boxes.
Can we use boxes? Yes, of course you can use your boxes. But remember, in the real world, we don't really use our boxes, right? So if you're going to do that, start taking off your boxes after, okay? So our number is 6,715. 6,715. He got it. Exactly. This is expanded form when you put the pluses. Good job. 6,715. The place value?
Remember your 10th place.
Oh, these are just place values. So you use that. This is 2 groups. How many groups do we have? No. How many groups do we have here? How many groups? 1, 2. So how many groups? 2 groups of. So 2 groups of 10, right? So if we did 2 times 10, what is that? Okay, so that's how we ended up getting our 20, right? 2 groups of 10. Now when we write the number 20, this is totally separate now. When we write the number 20, this is always a 1's place, and this is always a 10's place. So look at this. What number is this? 2 groups of, what place value is this?
600.
No, this is 2 groups of, yeah, that's how we got it. 2 groups of 10, 20. So 6,715. So if we're writing this in expanded form. Okay. That place value to you. No.
Another one.
What place value is this? No. And yeah, it's 1, 2, 3. Good job. So how many thousands do I have?
6,
But how many?
0, 0.
Okay.
Six,
How many
6,
zeros?
12,000, and then 7,
How many hundreds do I have?
100,000.
Watch this. How many zeros? How many tens do I have?
Because you would pay attention, see? Good things happen when you pay attention.
Or how many ones do I have? 5. So now what we do is obviously add
So
them.
far now we're
Plus 7. We go downwards, okay? There's 6,000s, so 6,000. There's 700s, 715. So you should be able to name big numbers for me next time. All right, we're gonna go over this. Don't worry, there will be plenty more examples. Let me close this. So 6,715. Okay, eyes at the board, please.
Okay.
Let me get different colors. Oh. Okay. So we have the number 6,000.
Oh, we do another one?
Yep. No, it's the same one. 715. Okay. First question. What am I missing in this number?
A comma.
A comma. Where does my comma go?
Next to the seven.
How did you know that? A comma goes after every.
Number.
No, a comma goes after every blank numbers. Yes, but every 1, 2, every 3 numbers. After every 3 numbers, there is a comma. After how many numbers? 3. After every 3 numbers, there is a comma. So 1, 2, 3, put a comma. Okay? Are we together so far?
Yes.
Okay. Now, here's my next question. What place value?
10.
Hold on, wait a minute. Okay, you guys can yell it out now. Okay. What place value is the 5 in? 1. What place value is the 1 in?
100, 1,000, and 1,000.
1,000. Good. Will this ever change?
Never.
No, it's always the same, no matter what number you're reading. Okay. So you got that to know. Now, look at the pattern. 0, 1, 0, 2 zeros, 3 zeros. So it's going to just keep increasing, okay? Now, for those of you who cannot see it yet, we have this is our thousands place, right?
Yeah.
How many thousands do we have?
6.
6. So look at what I do. How many zeros are there? 3. So look at this. 6,000. Oh. Okay? Does everybody see how I got this?
Yeah.
Okay. Now, what place value is this? 100. How many hundreds do I have?
7.
So look at this. How many zeros are here?
2.
So 700.
100.
Okay? Now, what place value is this?
10.
How many tens do I have?
Uno.
1. So how many zeros are here? Uno. 1. So look at what I do. I put the 1 and then the 0. What place value is this? 1. Are there any zeros here?
No.
So what am I going to put down here?
5.
5. Good.
I just got that right
You
now.
got 6.
Now look at what I do. Is everybody watching?
Yeah.
You see all these numbers?
Yes.
So I'm going to just add them now. I'm going to say 6,000
1,000.
plus
7,000.
700 plus 10 plus 5. Now, this is expanded form. Expand means to make bigger, right? So we just made this number bigger. Now, to read it, this is our what place?
6,000.
What? This is our thousands. What place is this? Hundreds, tens, and ones. So, look. How many thousands do we have? 6. So, 6,000. How many hundreds do we have? 700. How many tens do we have? 1. And how many ones do we have? 5. So 6,700. And what's this number? 15. 6,715. Okay? Are we understanding so far?
Yes.
Okay.
We gotta use these ones.
Okay, go ahead and turn off the lights, please. Thank you. Okay.
Into 6,000 because the 6 is in the thousands place.
Yep.
Plus 700 because the 7 is in the hundreds place. Plus 10 because the 1 is in the tens place. And 5 because the 5 is in the ones place. So the expanded form is 6,000 plus 700 plus 10 plus 5. All right, so do you see how our base 10 number system works? Number places are used to count different sized groups. Each group is 10 times bigger than the next, and the digits in the number places tell us how many of each group we have. The tricky part is that the number places are invisible, so you have to know how they work behind the scenes in order to make sense of multi-digit numbers. How do you like them apples? The exercises for this section will help you practice so that you get used to how place value works, which is super important if you want to be successful in math. As always, thanks for watching Mathantics, and I'll see you next time.
Thank you, bye.
What? That gives me an idea. I can make pies out of these.
Okay, so let's turn on the lights, please. In front of you, you have a note taker, okay? That note taker is also my check for understanding to see if you understand what we just learned. If you don't have it yet, it's okay. I'm going to take these papers and figure out who I need to reteach, okay? Is there a problem when I'm reteaching? No, it just means you take a little bit longer, okay? It's okay. So I want you guys to try and answer those.
Your brain is increasing.